According to the American Lung Association, we inhale 25,000 breaths each day. Clean, breathable air is a crucial aspect to human life and all of our respiratory health. For example, Philadelphia is a top 5 asthma capital in the United States, with pediatric rates roughly 4 times higher than the national average. Therefore, air quality monitoring in cities such as Philadelphia can add crucial insights to the dynamics between air pollution and human health. The burden of particulate matter and gaseous air pollution disproportionately affects communities with higher poverty rates and higher minority-majority populations. One approach to address this burden is to increase monitoring in these areas to better equip residents with more information to drive change through future policy decision-making. But the current level of government monitoring leaves many crucial gaps across the United States for air quality monitoring data. Therefore, we must turn to other techniques like low-cost sensing. I'm using low-cost purple air and Ogawa passive samplers to measure particulate matter, ozone, and nitrogen oxides air pollution at 15 sites in West Philadelphia over a 1.5-year study period. By deploying these low-cost sensors at residences, businesses, and schools, I partner with community members through a local environmental education center so that they can participate as citizen scientists directly and receive data updates about their local air quality. As you can see from the maps behind me, air pollution is not equal throughout West Philadelphia. Therefore, to identify hotspots in the community throughout the neighborhood, this study analyzes spatial trends related to land use, land cover, and transportation, in addition to temporal trends related to peak exposure times during rush hour, daily differences, or seasonal differences that can help explain the variation that we see in air pollution. After 1 year of sampling, 2 sites in West Philadelphia exceed the national PM 2.5 ambient air quality standard of 9 micrograms per cubic meter set by the Environmental Protection Agency, but no sites exceeded the nitrogen dioxide annual standard of 53 parts per billion. In landscape analysis, I found that areas with more paved surfaces experience higher pollution, while areas with more grass and shrubs experience lower pollution. The results also showed that sites with more vehicular traffic experience more nitrogen oxide gas pollution. Finally, I found that nitrogen oxides are higher in the spring than they are in the summer, and PM 2.5 is higher in both the summer and the winter than it is the rest of the year. By determining when and where air pollution is worse, my research will inform community members how to consider future policy and land development decisions that will in turn bring us cleaner air, healthier cities, and better lives. Thank you very much.